Guys, so we in class have spent the last couple of days talking about linear functions and how they look on a graph and in a table and how we see these things going. So I wanted to go ahead and fill out this summary sheet at the bottom of your notes with you. So what is a linear function? And that is just a function that has a constant rate of change. So we've seen in the last few days that the linear functions were very similar to arithmetic sequences. They have the same amount of change, they are always increasing or always decreasing, and their graphs are straight lines. So we're going to kind of put this into their key features. So remember that the slope will be represented by m, and it is the constant amount of the function changes by. It is your common difference. And so in a linear function, it will have a slope, but we'll find that other functions don't necessarily have a slope, but might have some sort of change. But in a linear function, it does have a constant rate of change. So it'll be the same amount of change per different level of number. The y-intercept will be the zero term or your initial amount when x is equal to 0. It'll always be, we can kind of also in context think about it as your base b, and we will represent it by b. So I've used these letters m and b, and so I just want to take a second to talk about the major linear function form is slope intercept form. And so you might remember this from middle school as y equals mx plus b, where the m is your slope and the b is your y-intercept. And so you can think of your slope also as d when we did arithmetic sequences, because those are one and the same. So we would be using slope-intercept form sum in this unit. So now looking at how it looks in a table, the first thing we want to note is that the amount of change between my x's is not the same. So I'm going from x equals 4 to x equals 6, which is a change of 2, and then a change of 4 from 6 to 10. So I want to keep that in mind when I look at my y values. From 16 to 24, that's not the next term. We're skipping term 5. So that went up 8. And then from 24 to 40, again, it's not that 40 is not the next term, it's actually the 10th term. So we're skipping terms 7, 8, and 9, and we're going up 16. So what we want to see is the amount of change between 16 and 24 the same as the amount of change between 24 and 40. So we want to figure out, well, what did it change per x? And so to do that, we would do 8 divided by 2, which gives us 4. And then we do 16 divided by 4, which gives us 4 as well. So the amount of change that it went up is actually the same, because this is dividing the amount of change for each one by how much change there was, which is what makes us know that it is a constant rate of change. When we look at a linear function on a graph, it will be a straight line that is always increasing or always decreasing. So it won't do both. So if we're increasing and we don't change. And if we are decreasing, we're decreasing, we don't change. And we can also remember that it can be a discrete function where there's just dots and still be linear, or it could be a continuous function in which we've connected the dots. So it matters is if the things in between matter or not. So that is our linear function. Just the key features that you need to be familiar with. We'll be working with these throughout the week and throughout this unit. So just make sure you're paying attention to these key features and what slope is and what y-intercept is and how we can find it in a table, because we'll do another type of function next week where we will compare them in the end.